You know that universally frustrating scenario where you sit down at your keyboard, you get into just an absolute state of flow, and you write what you're convinced is a brilliant, highly condensed piece of work.
Oh, yeah. Like you're completely in the zone.
Right, exactly. Like maybe it's a dense, mathematically perfect block of code, or, I mean, if you're not a programmer, think about a really complex, intricately worded email you send out to clarify a massive project across, multiple departments.
Right, yeah.
You hit send or you compile the code, and in that moment, you feel like a genius. But then you return to that exact same screen like a week later, read your own words, and realize you have absolutely no idea what any of it means.
It's the worst feeling. Because, the logic made perfect sense when all that contextual architecture was actively loaded into your short-term memory. You had the whole mental map laid out right there in your head.
Yeah.
But human short-term memory is incredibly volatile.
Mm.
Once that specific contextual map fades away, you are effectively reading the work of a total stranger.
A stranger who was, frankly, trying way too hard to show off.
Exactly. A stranger prioritizing their own cleverness over your future comprehension.
Well, when a developer named Ang sat down to parse some metadata in the programming language Haskell, they hit this exact wall. So today, we're pulling from a really fascinating blog post Ang published on June 2, 2026. It's titled Notes on Haskell Programming, Part 151.
It's a great read.
It really is. Ang was wrestling with this massive gap between writing, clever code and writing genuinely readable code. And more importantly, Ang's journey reveals how we have to navigate our AI tools to actually achieve that readability. So, okay, let's unpack this, because whether you are a seasoned programmer who lives and breathes this stuff, or someone just catching up on tech trends, or even just insanely curious about how human psychology intersects with machine logic, this deep dive is going to reveal a lot about how we communicate with our own tools.
Yeah, and to really grasp the psychology here, we have to look at the mechanical environment Ang was operating in, right? So Haskell is a functional programming language.
Which is different from, the usual stuff, right?
Very different. Unlike imperative languages where you tell the computer, do this step, then do this step, functional programming is much closer to pure mathematics. You're building complex equations.
Right.
And that mathematical precision is incredibly powerful, but it can lure developers into a stylistic trap. It's something known as point-free style.
Okay, I want to make sure we actually understand what that means, because the term point-free sounds like a weird loyalty rewards program to me. What is the actual mechanism there?
So that's a good way to put it.
Yeah.
So think of points as the actual data or the variables you're working with.
Okay.
In a normal sentence, you have a subject and a verb, like I throw the ball. In point-free programming, you essentially remove the subject. You string together a series of complex functions, the verbs, right, without ever explicitly naming the data they're acting upon.
Wait, really? No named variables at all?
None. You are just creating a pipeline of actions. So Ang originally wrote this point-free line of code using a string of base-level mathematical symbols and raw functions just to sort some metadata. No named variables, just pure condensed operations.
Man, it sounds like giving someone directions to the grocery store without ever mentioning the car, the roads, or the store itself. Like just telling them, turn left, accelerate, brake, turn right, stop.
Exactly.
Like technically accurate, maybe, but terrifying to execute because you have no idea what you're actually driving or where you're going.
That is a brilliant way to visualize the cognitive load it creates. You're forcing the reader to mentally hold all those raw operations in their head and sort of simulate the data moving through them.
Sounds exhausting.
It is. And Ang realized this. Ang actually labeled their own code an example of primitive obsession.
Primitive obsession.
Yeah. That happens when a developer relies so heavily on the absolute base level, primitive functions, and syntactical tricks of the language that they completely lose the narrative of what the application is actually supposed to be doing.
Oh, I get it. It's like trying to teach someone how to build a brick wall, but instead of talking about mortar and bricks, you only talk about, the atomic bonds of fired clay.
Yes. You're so zoomed in on the foundational grammar that you forget to tell the story of the house.
Right. So Ang looks at this dense, point-free code a week later, realizes it's a total nightmare to read, and attempts to fix it. And the first attempt is building a custom helper function, right?
Yeah, Ang built a specific step-by-step function to handle the metadata. The logic was pretty straightforward. If there is no metadata, just return the main body of the document. If there is metadata, grab it and attach it to the front of the body. It was explicit. It actually named the data.
Okay, better. But that custom function wasn't the final answer. The ultimate winner came from abandoning custom logic entirely and just pulling from the language's standard library.
Right.
Ang imported a pre-built tool called maybeToList. And I mean, even to a non-programmer, the phrase maybeToList sounds like plain English.
It really does.
It tells you exactly what the mechanism is doing. It takes something that might be there, the metadata, and converts it into a standardized list format.
What's fascinating here is the underlying data flow that makes this standard library solution so vastly superior. When you use a standardized tool like maybe maybeToList, you're taking abstract potential and forcing it into a concrete, universally understood structure, a list.
Oh, okay.
Once it's a list, it seamlessly merges with the rest of the document body.
Ah,
You're completely eliminating the need for the human reader to do mental gymnastics. They don't have to
yeah.
simulate the logic. They just read a universally accepted vocabulary word and instantly know how the data is behaving.
Okay, I have to push back on this a little bit, though, because I thought the entire appeal of functional programming languages like Haskell was their stripped-down mathematical conciseness. Like, by importing standard library functions and writing things out in plain English verbs, isn't Ang defeating the core purpose of the language? It feels like taking a sleek, aerodynamic sports car and bolting a bunch of heavy, explanatory bumper stickers all over it. Aren't you just turning it back into a clunky, verbose system?
See, that assumes conciseness and obfuscation are the same thing. And that is a very dangerous misconception in engineering.
Really?
How so? True mathematical elegance doesn't mean hiding the steps just to make the equation look shorter on the whiteboard. The purpose of a language like Haskell is to create highly reliable, predictable systems that don't crash. When you use standard library functions, you are leaning on heavily tested, universally understood architecture.
Ah, I see.
You aren't cluttering the sports car. You're using the standardized steering wheel instead of trying to invent a clever new way to turn the axles with a wrench. Clever code is inherently fragile because it depends on the reader sharing the exact same temporary mental state as the writer. Readable code is robust because it stands entirely on its own.
Okay, wow. The elegance is in the clarity, not the character count.
Exactly. The cognitive load optimization.
Right. And, Ang didn't just stumble onto this maybeToList solution through a textbook. It was discovered through a surprising external source, which actually brings us to an incredible dilemma playing out across the entire tech industry right now.
Oh, this part is fascinating.
Yeah, Ang fed the bad, unreadable code into a cutting-edge artificial intelligence model, and the AI handed back that perfect, elegant, standard library solution.
But there's a catch.
A huge catch.
Ang notes in the blog post that this highly readable solution was only discovered by utilizing a more advanced AI model. Crucially, this is a premium, cutting-edge model that's currently in a free trial phase, but almost certainly won't stay free.
Right.
When Ang tried to get the same elegant solution out of the basic, everyday AI models, they failed. They kept suggesting the same clever, unreadable garbage.
And this sparks a massive debate for Ang right in the middle of the post. Basically, should I subscribe to the current cutting-edge models? It's the classic subscription dilemma. But here's where it gets really interesting. Ang decides, at least for now, to stick with the basic model, to actively not subscribe to the cutting-edge one that demonstrably writes better code.
Which seems counterintuitive, right?
Totally. And the reasoning given is for study purposes and to keep the coding at a steady pace. But I have to ask, is Ang making a massive mistake here? Well, I mean, if a developer is obsessed with productivity and a premium AI demonstrably writes cleaner, more readable code that avoids primitive obsession, shouldn't they just pay the $20 a month for the upgrade? Deliberately sticking to a basic model that gives you worse answers feels like choosing to dig a ditch with a spoon when there's an excavator sitting right next to you.
If we connect this to the bigger picture of human cognition, Ang's decision is actually profoundly insightful about how we acquire and retain complex skills. We have to examine that phrase Ang uses, steady pace.
Okay, yeah. What does that mean in this context?
Relying on an advanced AI to instantly solve every architectural problem drastically speeds up your output, sure, but it completely short-circuits the steady pace of internalizing the language's logic. The friction of the struggle is the mechanism for learning.
Oh, I see. The friction builds the muscle memory.
Precisely. When you wrestle with that terrible, unreadable point-free code, and then you manually have to refactor it and figure out why the data flow is broken, you are building neural pathways. You're learning to recognize the anti-patterns.
And if the AI just does it all for you?
If an advanced AI just hands you the perfect standard library solution on a silver platter every single time, You never develop the critical eye to spot bad code yourself.
Mm.
Knowledge only becomes useful wisdom when it is deeply understood, not just copy-pasted from a premium chat window.
Wow, yeah. That is a really tough pill to swallow in an industry completely obsessed with productivity metrics, though.
Oh, absolutely.
We're so conditioned to believe that faster output equals better engineering. But Aang is actively choosing a speed limit. Aang is essentially saying, I need to go slow enough that my human brain can actually comprehend the terrain I'm driving through.
And that deliberate speed limit forces Aang into a secondary realization. If the decision is to stick with the basic, less capable AI model, then the burden of quality control shifts entirely back to the human.
Right.
It's no longer a question of buying a better machine. It becomes a question of being a more articulate communicator. How do you coax better, more readable solutions out of a basic AI that naturally wants to write bad code?
Which brings up a great question. Like, why do the basic AI models naturally want to write bad, unreadable code? If they have access to all the standard libraries, why do they default to that primitive obsession and those, clever tricks?
It comes down to their training data. Basic large language models are heavily trained on internet forums like Stack Overflow, where developers ask and answer questions.
Oh, of course.
And on those platforms, the answers that get heavily upvoted and rewarded are often the most mathematically dense, hyper-condensed, clever one-liners. They look incredibly impressive to other programmers.
So it's a popularity contest.
Exactly. So the AI learns a false equivalency. It learns that highly upvoted means good, and therefore assumes that dense, clever, point-free code is what human developers want. It's completely ignoring the fact that those one-liners are impossible to maintain in a decade-long enterprise project.
Huh. The AI is acting like a show-off computer science student trying to impress the professor rather than a seasoned engineer trying to build a stable bridge.
That is perfectly said.
So Aang realizes that to get good code out of this basic model, you have to actively constrain it. You have to learn prompt engineering. And Aang actually designs and shares 2 highly specific prompts aimed at forcing the AI out of its bad habits and prioritizing human readability.
Yeah, the first approach Aang details is the constraint-focused prompt. Aang explicitly feeds the AI the messy code and surrounds it with aggressive guardrails. The prompt specifically instructs the AI to avoid clever functional tricks and avoid complex partial applications.
Okay, to clarify complex partial applications, for the non-programmers listening, that's another mechanism where you create a function but only give it half the data it needs to run, right? So you're leaving it hovering in this weird abstract state, waiting for the rest of the data later. I imagine it's incredibly confusing to track.
It creates a massive cognitive burden because the reader has to remember this half-finished thought across multiple files of code.
Right.
By explicitly forbidding those partial applications in point-free styles, Aang is disarming the AI's tendency to show off. But the masterstroke of this prompt is the final sentence. Aang demands that the AI use standard library functions and then asks it to explain why your chosen approach is more maintainable.
I love that part. It is so much like managing a really talented but deeply erratic intern. You can't just hand them a file and say, fix this. You have to say, fix this, don't use any of your weird party tricks, use the standard company template, and write me a paragraph explaining why your fix won't break our servers tomorrow.
Exactly. Forcing the AI to articulate its reasoning acts as an additional layer of verification. It forces the model to evaluate its own output against the concept of long-term human maintenance.
Okay, so that's the tactical approach. What's the second prompt?
Which leads directly into it, yeah. If the first prompt was about tactical guardrails, the second takes a much broader philosophical approach to the architecture. Aang calls this the Ada philosophy prompt.
Oh, I found this fascinating. The prompt reads, I am working on a Haskell project where I want to prioritize readability, maintainability, and safety over syntactic brevity, similar to the Ada philosophy. Can you suggest a way to implement this that is idiomatic but remains easy for a junior developer to understand?
The invocation of the Ada philosophy is a heavy anchor here. Ada is a programming language originally commissioned by the Department of Defense in the late 1970s.
Wow, okay.
Yeah, it was designed specifically for embedded systems where a crash could mean literal life or death. Think avionics in fighter jets, air traffic control systems, or medical pacemakers. In those environments, you do not want clever code. You want boring, hyper-predictable, infinitely readable code. Aang is telling the AI to adopt the mindset of an engineer building a pacemaker, prioritizing safety over brevity.
The philosophy makes total sense, but honestly, the target audience Aang sets in this prompt really caught my eye, and I have to challenge the psychology of it.
Okay, let's hear it.
Aang tells the AI to write code that is easy for a junior developer to understand. Now, in the tech industry, developers spend years grinding away specifically so they are not junior developers anymore.
Oh, for sure.
There is massive ego involved in seniority. Telling an advanced developer working on complex Haskell architecture to write code a beginner could understand feels like an insult. Isn't that just a polite way of demanding that they dumb the project down? Like, why cater to the lowest common denominator?
That reaction is incredibly common, and it's entirely driven by the ego you just mentioned. But it fundamentally misunderstands what true engineering expertise looks like in practice. Making complex ideas simple is the ultimate hallmark of mastery.
Hmm.
Dumbing down implies you're stripping away functionality or precision to make something digestible. What Ang is asking for is not a reduction in capability, it's a demand for total clarity. When you write code that a junior developer can understand, you aren't writing beginner code. You are writing highly articulate, transparent code.
So it's about removing the ego from the compiler and thinking about the life cycle of the product.
The reality of software engineering is that the original author of a piece of code is rarely the only person who will ever touch it. Enterprise systems live for years, sometimes decades. They require constant long-term maintenance from a rotating cast of team members.
Right. People leave, new people get hired.
Exactly. If you use custom logic and unnecessary abstraction, if you write code that only a senior developer with 10 years of Haskell experience and a PhD in mathematics can parse, you're introducing massive systemic risk. You're making the entire application fragile. Standardizing around readable, junior-level clarity drastically reduces errors because anyone on the team can pull up the file, instantly spot the bug, and safely push an update without breaking the entire architecture.
So the junior developer in this prompt isn't an insult, and it isn't even necessarily a literal 22-year-old recent graduate.
Not at all.
The junior developer is essentially a proxy for anyone who hasn't spent the last 6 months staring at this exact hyper-specific problem, which ironically includes yourself a week from now.
You are your own junior developer when you come back to that screen after a vacation. Your contextual memory is gone. By invoking the it philosophy and the junior developer persona, Ang is forcing the AI to optimize for human memory and human teamwork rather than mathematical brevity. It's a brilliant psychological hack to get a high-level, mature result out of a basic tool.
Man, that's wild. So what does this all mean? If we look at the entire arc of Ang's blog post, starting with that messy, point-free, primitive obsession, moving through the temptation to just buy a premium AI to fix the problem, and finally landing on these meticulously engineered, constraint-heavy prompts. Well, it distills down to a really powerful lesson about cognitive load. True elegance in your work, whether it's Haskell code, a quarterly board presentation, or a massive project plan, isn't about proving how clever you are.
Not at all.
It's not about using the biggest words, the densest acronyms, or the most condensed syntax. It's entirely about how easily someone else can decode your logic.
It requires a paradigm shift, really, from writing for the machine compiler to writing for the human maintainer. The machine compiler can understand the dense, point-free code in a millisecond. The human mind cannot. And ultimately, it's human beings who have to live with, maintain, and fix the systems we build.
And there is a direct, immediate application here for you listening right now. The next time you open up an AI tool, whether you're trying to write a script, draft a sensitive email, or brainstorm a project architecture, do not just ask the machine for an answer.
It'll just try to show off.
Exactly. The AI will naturally want to show off. Take Ang's approach. Treat it like that erratic intern. Set strict constraints. Demand readability. Explicitly forbid clever tricks. And force the AI to explain its reasoning. You will get a completely different, much higher quality of output, even from a free basic model, because you're forcing it to communicate like a human being.
Which, actually leaves us with a rather profound, slightly unsettling question to consider about the future of this human-machine dynamic.
Oh, what's that?
Well, we're talking about using prompts to force AI to write readable code. But what happens if prompt engineering eventually gets so good and these models become so perfectly aligned that they consistently write flawlessly readable, maintainable, junior developer-friendly code on the very first try every single time?
I mean, if the AI never spits out the dense, clever stuff anymore, we never have to struggle to read it.
Right. And if we never struggle to read it, do we lose the muscle entirely?
Oh, wow.
We might be rapidly entering an era where future developers become incredibly articulate AI directors. They'll be masters of shaping logic perfectly through constraints, philosophy, and prompting. But in doing so, they might completely lose the foundational skill to decode the messy, point-free, complex legacy code written by human beings just a generation before them.
It goes right back to that blank stare at the screen we started with. You write the dense code, you step away, and the context is gone. Only in this near future, it might not just be your own code you can't read. It might be the entire foundational architecture of the internet, written by the people who came before you, rendered completely incomprehensible because we outsourced the friction of understanding to a machine.